Hello there, Mr. Sutton here with the Pre-Cal Honors 6-2 Part 2 homework solutions on vectors. For this problem, we want the component form of a to b and then absolute value or magnitude of the vector ab in simplest radical form. So to get the component form, we need to do x2 minus x1, comma y2 minus y1, so 3 minus 1. And then we also need negative 5 minus negative 2, or plus 2. So that gives us the component form of 2, comma, negative 3. And now to get the magnitude, we just have to Pythagorize this, find the Pythagorean theorem of this thing. So square root of 2 squared plus negative 3 quantities squared. This is going to be 4 plus 9, which is 13, and that's as simple as it gets, square root of 13. To find the component form for the vector that goes from A to B, we need to do essentially point B minus point A to find the difference. So we're going to have negative 5 minus negative 3 for the x values, or plus 3, comma, 1 plus 5, or minus negative 5, giving us the component form of negative 2, comma, 6. Now for the magnitude, we're just doing Pythagorean theorem of our component form. So that's going to be the square root of negative 2 squared plus 6 squared. That's 4 plus 36, which is square root of 40. We can take out a 4 and square root it, so that's going to be 2 radical 10 if we simplify it. Given these vectors up here, we're trying to find u plus v, so let's replace those with the actual component forms. So 3 comma 1 plus negative 8 comma 4. And then we're just going to add the x's and add the y's separately. So we're going to have 3 plus negative 8, or 3 minus 8, comma 1 plus 4, giving us the final answer of negative 5, comma 5. Given these vectors up here, to do u minus w, we'll start by replacing these variables with the component forms. So we have 3 comma 1 minus negative 6 comma negative 2. And now we're just going to subtract the x's and the y's separately. So we'll have 3 minus negative 6, or plus 6, comma 1 plus 2, giving us the final answer of 9, comma 3 for the vector. To do 8 times the vector v, let's replace the variable v with the component form of negative 8, comma 4. Next, we just have to distribute the 8 to both of these. So this is going to give us the vector negative 64, comma 8 times 4 gives us 32. To do 3u plus w, we're going to replace these vector variables with the component forms they gave us up here. So we've got 3 times 3 comma 1 plus negative 6 comma negative 2. We're just going to do order of operations here, PEMDAS. We're going to do multiplying before we do any adding. So distributing this 3, we've got 9 comma 3 for that first vector. Second vector, we're not changing just yet. Now to add these two vectors together, we're going to add the x's and the y's separately. So we have 9 plus negative 6, or 9 minus 6, comma 3 plus negative 2, or minus 2, giving us 3 comma 1. To do v divided by 2 minus 5w, let's replace these vector variables with their component forms. So this first piece, we've got negative 8 comma 4 over 2, and then we'll have minus 5 times negative 6 comma negative 2. So we're just going to distribute the division and the multiplication to each individual vector. We'll do that before we try to subtract anything. So over here, this is going to be negative 4 comma 2, just dividing both of those things by 2. Next, I'm just going to distribute a 5 inside here, and I'm going to leave the minus outside to deal with later. So inside we're going to have negative 30 comma negative 10. Again, I have not distributed this negative yet, although I could have. Now I'm going to go ahead and just subtract here. So I've got negative 4 minus negative 30 for the x's, or negative 4 plus 30. Doing the y value separately now, I've got 2 minus negative 10, or 2 plus 10. So this comes out to the final answer of 26, comma 12. For this problem, we're doing 2 times v plus w in a parentheses. Now there's a few ways you could do this problem. You could, if you wanted to, actually distribute this 2 to both of these vector variables and then go from there. Or you could immediately add these vectors together and then multiply it by the constant 2. I'd take the second approach myself. So I'm going to replace the v and the w with negative 8 comma 4 plus negative 6 comma negative 2 inside of big parentheses now. Now I'm going to add these vectors inside here. So I still have my 2 out here, and inside I have negative 8 plus negative 6, or negative 8 minus 6, either way, comma 4 minus 2. So this is going to be 2 times the vector negative 14 comma 2. Next, we're going to distribute the 2 to each of those individual coordinates. So we've got negative 28 comma 4. For this problem, we're trying to take the absolute value of u and w and add those together. So I have to take care of the absolute value before anything else. Now, absolute value, remember, really just means Pythagorean theorem when you're dealing with vectors. So let me start by writing the component forms, and then we'll go from there. So we've got absolute value of 3 comma 1 plus absolute value of, this will be negative 6 comma negative 2. And again, we're just using Pythagorean theorem on each of these vectors. So this first one is the square root of 3 squared plus 1 squared. Adding that to this other one, this is going to be the square root of negative 6 squared plus negative 2 squared. Over on the left here, this is just the square root of 10. On the right, we've got the square root of 36 plus 4, square root of 40. 40, we could simplify if we split this up into 4 and 10 as 2 radical 10. And then 1 radical 10 plus 2 radical 10 is 3 radical 10. To find the dot product of these two vectors, we have to multiply the x's and the y's and then add those products together. So we've got 3 times 7 plus negative 5 times 4. So 21 plus negative 20, which gives us 1. To find the dot product for this problem, we need to do the x's multiplied together, so 10 times negative 7, plus the product of the y values, so plus 16 times negative 3. And now let's simplify this. So we have negative 70 minus 48, which comes out to negative 118. On this problem, we have to do negative 2 times the dot product of u and v. Now there's a few ways you could do this. If you want to multiply the negative 2 by the u, and then whatever you get out of that, dot multiply it by v, that's one option. I chose to do u and v dot multiplied together and then distribute the negative 2 at the end, but there's other ways to do it. So I'm going to replace the u and the v with their component forms. We're going to have 4 comma 2 and negative 8 comma 3. Plug in all that in. So there's the negative 2, there's the component form for u, component form for v. I'm now going to dot multiply this stuff inside here. So I'm going to have a negative 2 outside. Inside, I've got 4 times negative 8 plus 2 times 3. X times x plus y times y. So this is negative 2 times, and this is going to be negative 32 plus 6, which is negative 26. Multiplying that with the negative 2 that's already there, we end up with 52. For this last problem, I've got v times u plus w. One way you could do this is distribute the v to the u and the w, just like normal multiplication. I, on the other hand, decided to just add u and w inside and then dot multiply it by v. So let's start by replacing everything with the component form. We've got negative 8 comma 3 out here, and inside we've got 4 comma 2 plus 9 comma negative 11. So I'm going to add the stuff inside here first. That's pretty easy to do. So we've got negative 8 comma 3 times, and now we have 4 plus 9, which is 13, and 2 plus negative 11, which is negative 9. Now I'll dot multiply. So we've got x times x, negative 8 times 13, plus y times y, 3 times negative 9. This is, let's see here, negative 80 plus negative 24. That's negative 104 minus 27, which comes out to negative 131.